So here we have air, a film of oil, and water. When you put your eye here, it's reflected green. So we just want to find out what's the minimum thickness of the oil for it to reflect green. There's two rays reflected, right? The first ray reflects off of a higher index, which is 1.5. So we're going to add a pi here. The second ray, it's a lower one. It's from 1.5 to 1.3. That one's just 0. This one we can say doesn't travel through any medium, although it is air, but we won't count it. This one does, it's oil. And then it doesn't go through water at all. It reflects off of it. So for that path that it travels through the oil, we have this equation here. We take the difference, but before we actually do that, we need to set it equal to something, because if we just have this, like, how do we solve for anything? Since we see the green light, it's constructive interference, and that's going to be 2m pi. Move some stuff around, and we can solve for t. M is going to equal 1, so I'll just remove n. We can't do 0 for whatever reason. Plug it in. I'm getting 268 nanometers. Double check. Apparently it's wrong. 178. DeepSeek is saying it's 59, bro. It's using 0 as an M. Claude is saying it's 89, bro. All three of them got different answers. So which one is it? Of course it's 268. What else would it be? I see why it's 89. If you do M0, apparently it could be 0. It doesn't become negative or anything like that. But instead of simplifying to 3/4, it just simplifies to the lower odd, which would just be 1. And you redo everything. And of course, it's 89.2, which is what we had over here, 89.2. Also, I asked Gemini again, but this time with the picture, and it is 89.2.